sessions on competing. We're going to have a success story on how we compete with others. So I'm glad you're here for this day. We have a keynote where we're going to be talking about bandwidth as a lie, right? And what does that look like, and what are we doing? So we have a full panel up here, a lot of great information to share with you, and I'm going to turn it over to Frank. Thank you so much.
Should I use this mic?
Sure.
Yes.
Yeah. You can take. There you go.
We good, Tommy? Okay. Yep. Oh, so let's do this. Thank you very much, everybody, to coming in. So this panel was meant to be run by Dave Techt. He is the guy that basically started the whole fight against latency, buffer bloat, and jitter. But he died this year, sadly in April. So I am trying to pick up the torch and to continue his work. And as you know, probably he was working on Codel, FQCodel, and Cake. It's part of mainline Linux. It's in OpenWRT. It's in Starlink. So it's helping Elon Musk to compete with you. And basically, Starlink has a better latency than most of you and most of the ISPs, terrestrial ISPs in the world, which is shame. But you can fix that quite easily with, for example, using quality of experience middle boxes. And we have quite a few examples that can really help you to fight Elon and pretty much anyone else of your competitors. So let's go through some really simple explanations, and I encourage you to take the photos of the links, and you can read way more about the topic. And so probably most of you knows Justin Wilson. So he published this really simple explanation of how our internet basically works. There is also some big guys that are coming to Jesus, and they are realizing that bandwidth is not everything, and we are living basically in a post-bandwidth world. This is also a really simple explanation how internet really works and what we need to take care of. And this is not everything. Jason Livinggood of Comcast, he's really pushing change inside the corporate of Comcast, and they are really getting better, especially with Xfinity using L4S, and they will be competing with you. So there are at least two things that you can make better than them. One of them is customer service, and you are doing it really well. And latency is something that L4S is really good, and it's way better thing than Doxy Spy. But you can get even better because there are solutions that we do believe are better than L4S. So buffer bloat. A couple of years ago, most of you would argue that buffer bloat doesn't exist, and you will just throw the bandwidth on it. You will get the big pipe, and everything will be fixed. But that's not true. Solutions to buffer bloat are well known for at least since 2010. They are Codel, FQCodel, and Cake. You can also read RFCs and a scientific paper for Cake, where it's really well explained. There are some new up-and-coming solutions, and you will heard of them in the future. Cake Auto Rate, for example, was built because LTE and 5G and Starlink at the very beginning was really terrible. So one lawyer in Scotland decided to write an algorithm that will fix 5G, basically. L4S is coming, and it's used by Apple, for example. It's used by Fastly, Cloudflare, NVIDIA, and T-Mobile in the US is rumored to test it. Vodafone in UK, Deutsche Telekom in Germany. So it's coming everywhere. And currently it's deployed on something like 10 million devices at Xfinity network. There is also improvements on Cake in Works. One of them is Cake MQ, multi-queue. It will fix one of the inherent problems of Cake. The other thing done by wonderful people in India is called FQPy. Then there is another potential improvement in Cake called Purple. It's done by a former PhD student in New Zealand. Then there is another metric that's coming to the world. It's called quality of outcome. You can also read about it. And then one of the instrumental people that developed Cake with Dave Techt, Jonathan Morton, is working also on the next generation of queuing discipline. Some of you are using routers that are having Cake or F2CODL inside, but to do this latency mitigation only in the router at the customer premise is not enough. If you are not using these routers that are supporting it, to really change all the routers in your customer base, it's almost impossible for the most part. And if something, it's really expensive. Therefore, we will argue that this kind of middle box in your network can really help you to get things improved. And so it's my great pleasure to introduce you our panelists today. Alexander of AppLogic, he flew here right from another event in Europe, in Paris, Network X. He flew here around midnight, so he's like, it's really amazing that he came here just for this panel. And for those people that doesn't know, the company was formerly Sunwine, and probably every one of you heard about the company. Then we are happy to welcome Jose of Bequant, Dmitry from Cambium. Everybody knows Dmitry. Everybody knows Dan from Preseem. And there is Ajith Pasqual of Paraqum. Not many of you know him, but they are another wonderful company. And last but not least, there is my colleague, Herbert of LibreQoS. And like at this panel, I'm not wearing LibreQoS hat, right? So I'm here to encourage the other solutions that are on the market to explain their point of view. And maybe you will find it really useful for your networks, especially in the future, because more and more applications that we are using on the internet nowadays and we will be using in the future will be latency sensitive. And right now we are talking about milliseconds, but we are coming to the microseconds territory. And so let's start, if I may. Alexander, can you tell us about your approach at the company?
Our approach to queuing? Good question. Hey everyone. I started doing active queue management and queuing in 2001. Probably the only one that did AQM before me was Sally Floyd, who's also unfortunately no longer with us. She was the inventor of RED, a random orbit drop, if you've heard of that. So I've gone through a lot of different queuing mechanisms over my career. And one thing that I think all of the middle boxes here have in common is an ability to do quite a bit per packet compared to a router or something that is hardware accelerated. So we pretty early started doing queuing per flow. When you hear the term fair queuing and multi-queue and flow queue, etc., just think of analytics that runs per flow, looks at what the flow is doing, and then does queue adaptions to that. So our approach to queuing right now is a leaky bucket. For those of you who know what that is, we started, before that we actually had a strict priority queue. And one of the things that we do that is quite unique as well is what we call distributed queuing. So if you have more than one box, let's say 100 boxes, and they all need to share the same queue, it's a really difficult problem to solve, distributed queuing, and that's something that AppLogic has done for quite a while. Then on top of that, of course, I mean, this is not a half-an-hour lecture, but you have to deal with shapers, you have to deal with different priorities, you have to deal with different types of tags, div-serv code point tags, you have to deal with L4S traffic, marking it and understanding it, etc. There's a lot in queuing, but if you want really good outcomes, start by understanding how your traffic is behaving, and then pick a queuing mechanism that solves that problem, and keep monitoring the quality of experience. Maybe you picked the wrong one, and then move on from there. I'll shut up.
Thank you very much.
Hi, Dan from Preseem. So asking us about queuing is going to be a long conversation, I think, because we've all been doing this a very, very long time. Yeah, so for me, I've been playing on buffer bloat stuff for a long time. So our approach initially was FQ based, and then we extended that beyond some tweaks to that algorithm. More recently, we moved to our own system that we just kind of built from scratch, from the ground up, virtual clock based, per flow queuing, et cetera. So ultimately, though, I think a lot of these low-level details, while interesting, are probably not why everybody's here today.
Okay, so Dmitry from Cambium, and you know Cambium from the wireless side of business, and we were always addressing queuing on the radio side first. And some years back, I've met Dave, and I've met our colleagues from Bequant, and I was mind blown with the idea that we can move away from doing some magic, basically queuing that we are doing inside the radio, because the radio is always limited with the horsepower, and as much as we want to do some fancy algorithms in terms of like per flow queuing with many queues, with many flows, it's a challenge. So I was always passionate about bringing QoE. I typically tell everybody who comes to Cambium's booth that the number one thing that you need a QoE box to do the shaping properly, because many times it's like ruining the experience. But again, I'm not here to sell. So.
Hello, good morning, Ajith from Paraqum. We started using FQ and then actually we switched to K. Our queuing approach is pretty much, as already mentioned, flow-based. But from the inception, we've been very focused on three aspects. That's basically the user experience, quality experience for the user and the application, and also for the ISP as well. Like, so we right from the beginning, we basically say, okay, we provide the tools and you manage your own network. I think the IP and the flow-based queuing actually has really helped us to give the overall visibility of the entire network. And most importantly, like to do the every application requires a different sort of resource requirements. I think we are DPI enabled shaping, so that actually gives us the context awareness, and that's actually we link that with the flow-based and IP-based queuing. Thanks.
Hello, everyone. At Bequant, we do a very engineering-based approach. The problem is that we have a limit somewhere in the network, and then there are more packets coming in than they can come out. So when you then you will build a queue, and that queue means latency. So what can you do about that? Because there will be limits. There are your subscriber rate plans. There will be Wi-Fi routers. They're limiting. That's because of their capacity or people being away from them. So what can you do? Two things basically. Because one thing is to assign more priority to things that suffer more with latency, like for instance voice over IP or gaming traffic. So if you can make those packets, which usually are few, jump the queue, then you have done something. Because you still have the latency, but maybe it's affecting Netflix and other applications which really don't care very much. But even so, that's the first thing. The second thing, you have to convince somehow the sender to send at the speed of the limit. If you have a limit at 40 and you send at 41, you build a queue. If you send at 39.5, you don't build a queue. So you have to get the sender to send at the right speed. And there are different ways. If you have for TCP flows, if you have TCP proxy, that would be the best way, because with TCP proxy, you can, with the receive window, tell the sender at exactly what speed. If you for non-TCP, then you have FQ-Codel, you have Cake, you have then going forward these advanced ways to do Cake and other Q disciplines, but also L4S. And so that's also what we do. But the problem is that we have a problem in the future, because we are doing all these things in these little boxes, but when you do a 1 gig rate plan, what happens? People, how often do they hit 1 gig? Only when they do speed tests. So when they are not at 1 gig, they are really, we are there not doing much, because if the limit is at 80, because some Wi-Fi router in the path is enforcing that, it's limited to that speed. So we have to do things to basically be able to discover those situations and try to enforce limit at, if it is an 83 megabits limit that there is, try to do 82. So it's always about getting to a little below the speed. So that's our approach.
I joined LibreQoS thanks to Dave Todd telling me that he just found someone crazy. He thought he might have found someone crazy enough to take this on. So I sort of went on a big crash course, and my first response was, wait, we fixed buffers by adding more buffers? And it's true. You add, it's true. You add in smart buffer, and it's kind of remarkable how everything starts to look. One of the things we do is we try and map the hierarchy of the network as a whole. So we've got a token bucket. I think somebody said they have a leaky bucket. We have the Linux built-in one with multiple priority levels, ceiling and commit rates, all that good stuff. It actually adds some buffer bloat. So you also need to add either FQ-Codel or Cake to take that away. And so, I always thought it was kind of ironic that we're adding bloat at one end and fixing it at the other. But Cake is kind of magical, because there's a big misconception that Cake isn't doing anything when you're not filling your pipe. And that's not true, because the Cobalt algorithm is actually adding timestamps to every single packet and making sure that any packet that has been in the queue for too long gets dropped. And that allows you to be protocol neutral and still apply pacing to sane algorithms. Anything using TCP, anything using QUIC, we'll notice that, hey, you're dropping some of these packets, it will start to self-pace. And that way we don't have to know exactly what's in the packet, we don't have to violate privacy, but we can still deliver a really top-rate overall network performance. And Cake on the second level looks at what general type of traffic things are, divides them up into tins, gives some priority. So if it looks like VoIP, it gets the highest priority. Looks like a Zoom call, high priority. Looks like Jimmy in the basement is downloading Call of Duty 6 while you're trying to have a meeting, low priority. And that's kind of how it should be. We add queues to fix queues, which makes no sense conceptually until you start realizing just how magical some of these algorithms really are. And as we move forward, the algorithms get refined. We're trying to work with the Linux people to make some of these algorithms better, and in some cases document what they do. Like HTTP has been around a very long time. The source code is truly terrifying. So figuring out exactly how it works is sometimes a challenge.
Thank you very much, everybody. Let's move forward. So everybody is looking for a big pipe, right? So we should take a look on this.
I think I wrote about this a couple of years ago on how much bandwidth do you really need. It's not 10 gigs. People like overestimate the need for bandwidth like crazy. How much do you think is the average peak throughput in a mobile network over the course of a day? Like if you take all of the users in a mobile network or in a fixed network, how much bandwidth do they really use, not need? And it's something like 8 to 12 megabits in a mobile network, maybe 12 to 20 megabits in a fixed network. That doesn't mean that you can't take advantage of 100 or maybe a gig if you're doing a download and it downloads in 30 seconds instead of 2 minutes. If that's a game update or whatever, that's good. But I mean, I agree with frankly that bandwidth is a lie. And I think stopping selling on throughput and then starting to sell on QoE, on low latency, on good quality of experience is absolutely the way to go. But we also need to live in the real world. If the competitors sell the 10 gig, you probably have to offer 10 gig too, but offer it better than them would be my recommendation.
Thanks. Yeah, so we have a lot of data. I guess probably many people in the audience look at our network report that we publish every year, and it's based on a lot of people in this room. So yeah, typical usage during peak is like 5 megabits per second. There's also a really interesting chart in there showing how subscriber behavior changes with plan rate, and after about 20 meg, it really doesn't change a lot. So the good news is you can sell bigger plans. You're not going to drive a lot of load in your network. But the bad news is people do want to buy 10 gig plans, and eventually we're going to have to do that. If the question here is about like 10 gig, maybe in the context of traffic management, I think that's a bit of an open question. I don't, everybody's going to have a slightly different opinion here, but does it matter quite as much to prioritize if everyone truly had 10 gig to their home? Or certainly, we keep name dropping L4S as a future technology as well. That also makes a really significant difference on latency without having, extra queuing systems and stuff in place. So I'll be a little contrarian and say I think we don't really exactly know how this all figures in a world if people truly have 10 gig. But fortunately, most of the market's not going to have 10 gig from home for quite a while.
Great. So I believe that was a great idea on one of your slides, that basically the speed is a proxy for the quality, kind of. So the customer perception of the speed is that the higher speed equals the better quality. And we kind of, we as the whole industry, right, we are pitching them that the higher speed you have, the better your experience with whatever Call of Duty or Teams calls, whatever. And I don't think we're doing a really good job to change this perception. And it's a wider problem. It's not only in the wireless ISP, right? It's mobile networks, everything. The challenge that we see as a vendor, like a radio vendor, with a 10 gig, for example, and that's where the QoE is very important, that I believe many people are long enough in the industry, and you remember when we were getting from like 100 to gigabit, there was like 100 megabit, Ethernet was a standard, and we were getting to gigabit. And then there was a traditional issue when you have like a gigabit link going to 100. And if you have like micro spikes of data that are going up to gigabit, you have to squeeze them in 100 megabit data link. Either it is on the switch, on the router, on the radio. Then there is a buffer bloat, naturally, because you have like a spike of data that is coming really fast. And now getting to the 10 gigabit era, we are seeing it at completely different scale. So the challenge is that now we have most of the network built on the 10 gigabit, right? But your access network is typically gigabit. It's either on the tower, it's either at the access at the customer, and it naturally introduces the buffer bloat because the speed test server, it can generate spikes up to 10 gigabit now. And your network, like end-to-end, have to digest it somehow. Without QoE, you will have, if you look at the microsecond level of data, there will be like a high spikes. And you think, oh, I have 10 gigabit here, I have a great test results with, I don't know, MikroTik bandwidth, and then I run my speed test, and it is not that high. And that's exactly the reason why you are not getting it. And unfortunately, the only way to solve this problem is to have QoE of some sort. Well, it depends. If you do it at even in your core, and if you do it properly, you will not at least have the 10 gigabit spikes. You will have it at your data package, like 300 or 200. So, and that's why it is important, at least, to get rid of those spikes that are going to 10 gigabit speeds.
Sort of similar perspective, I think if I rephrase this, whether 10 gigabit per second actually will give you always a lower latency, well, it's not. And there is a general perception that fiber, like you don't need actually middle boxes at all. But when you go to how the TCP actually behaves, is larger the pipe, actually TCP actually will give you send data as fast as possible. So whatever the limit that you have, 1G or 10G, you will actually see spikes. And every spike will actually introduce a latency, no matter how small that is a latency. It could be 1 millisecond, 2 milliseconds. When they add up, they always actually give the latency actually will always go up. So unless you manage those latencies, or the spikes actually will be there in pretty much every application, not just speed test. And only way that you can actually manage will be properly a QoE box in the middle. And that would actually make sure that, and starting from the basic question, like bandwidth is a lie, I would say beyond a particular point, bandwidth is a lie. And you would actually need a certain optimal bandwidth, but it's not gigabits per second. I mean, probably 100 megabits per second, actually more than what you need for a lot of applications for the highest quality of experience. But whatever the speed, whether it's fiber, regardless of the access control, you would actually need a QoE box to manage the spikes, because all the applications by nature will actually have these the spikes inbuilt. Whenever you hit the limit, you will have to retransmit, and that get buffered. Even if packets do not get lost, still it will be buffered. It means actually introducing additional latency.
Yeah, well, 10 gigabits would be really good, but for a 2,000 subscriber ISP. But I guess commercially, you will at some point be in the near future, I don't know, but even it doesn't make sense, you'll be forced to offer that. And when you do, you'll need to be ready for speed tests to get to that number, because it'll be basically with speed tests that they'll hit those numbers. Well, maybe also when they do large downloads for PlayStation, software updates, things like that, but very few other situations. However, your customers will have this 10 gig subscription, but they will still have Wi-Fi, and they will still have walls, and they will still have people around the house far from that Wi-Fi. And so in those situations, you'll still have limits. There will be limits in the, and at much lower speed than 10 gigs, and there will be then delays and latency. And so you have to be ready for that, even though they have that 10 gig, to solve their problems when they have those limits maybe at 80 or 100, whatever they pick at with their in-home devices.
You know, it's funny, where I live, a fiber company rolled out 10 gig to the home, and 2 weeks later they were telling people you can now get 9 gigs to the home. And a month later they were saying 5, and it's down to 2 now. And the reason for that is I think they thought they planned on the basis if they would get 1 subscriber. And a lot of the neighborhoods signed up. And funnily enough, that 10 gigs all funnels down to 1 fiber device, all funnels back to 1 backhaul, all funnels back to 1 set of routers, and then goes out to the internet as a whole. And to build on what they were saying, 10 gigs is great, but that's assuming that everything works. There's no congestion anywhere between point A and point B. And you guys run ISPs, you probably know that everything works every day perfectly all the time, and you've never had a call out at 2 in the morning. If that's the case, please raise your hand and I will bow to you. But in general, something always goes wrong. And so QoE helps partly because we live in an imperfect world.
And like they said, it helps because microbursting traffic is happening all the time, and the applications that are bursting are largely unaware of each other. And so you end up with buffers everywhere. And when you start getting up to really big speeds, the buffers honestly get kind of huge sometimes. Vendors are getting much better about not just making everything pass through an enormous buffer when it doesn't have to. But as soon as anything has to change rate for whatever reason, it might even just be that your fiber demodulated for a split second because somebody hit it with a tractor and didn't actually manage to cut it. It's anything anywhere on the path changes, you're going to start getting buffering appearing. And if you're doing per flow packet pacing, which is the speed that the packets are going through the pipe, then it doesn't really matter how big your pipe is, it's what you do with it. And spacing the packets through it at an appropriate rate for where they're going and what they're doing makes more of a difference in terms of feeling like you have a good connection than having a big number. But unfortunately, this is America and big numbers sell.
I think what Alexander said there at the beginning is really important, right? People want to buy big numbers, and Herbert touched on that too. There's a really interesting thing, if you get a chance to look at it, that Apple's been working on, the RPM. You've probably looked at this a bunch, right? And it's basically what they're trying to do is define a metric that goes up when the network is better instead of down, right? Because people intuitively want to see big numbers. So if you get a chance, it's like draft responsiveness, and some Apple people own it. But
network responsiveness.
Yeah.
Put Apple together into the search and you will find it.
Right. Yeah. So I think it's built into, I'm not a Mac guy, but it's built into Mac's network quality tools and stuff already. And it's really neat, right? Because the better the network gets, the number goes up. So maybe someday we live in a world where we have two big numbers we can sell. But the reality is right now, people just look at bandwidth, unfortunately. We all know that.
Thank you then. And it's also connected with L4S. So Apple is basically, if you have a new iPhone, it's in there already.
So if we're also being real, the big problem with QoE today is Wi-Fi. Let's not forget, it's not anything else. And Wi-Fi is significantly worse than the normal mobile scheduler. Wi-Fi does not protect one device from another. There's no isolation. In Wi-Fi, you can self-congest on one device by downloading a ton, and you'll build buffer bloat. And you can also congest for your neighbor on the same cell very easily by doing a download or upload or whatever, and that builds latency for everyone else. That's the problem. These AQMs that we're talking about, they help, but then for them to help at that level, you normally have to be in the access point running the Wi-Fi scheduler yourself. Doing an AQM upstream doesn't help necessarily with that problem, unless you see that the round-trip time of the flows that are going on the Wi-Fi is increasing, even though your queue is not full or filling up at all. So that could be a nice signal to say, okay, I'm going to take the heaviest flow or some of the heavy flows, I'm going to shape them down, just like we were talking about, you go from 40 to 39, you're not building any latency anymore. Well, keep doing that, and eventually Wi-Fi will actually become good. Maybe we, as middle boxes, will figure out how to do that very well before Wi-Fi gets better, at Wi-Fi 8 or Wi-Fi 9 or Wi-Fi 10 or whatever. We'll see who gets there first. But today, that is a dirty, dirty problem that we're not solving.
Thank you very much. Yeah, so this is something that everybody thinks that middle boxes are just in the ISP networks, but that's not true. So there is way, way, way more deployments, and I would like to hear from everybody if they can share something that's not, secret.
I guess I'll start. QA use cases. I told you before, Frank, we were talking. One of the biggest impacts from getting control of your traffic, understanding QA, managing it, etc., is the support center. It's remarkable how much better quality becomes and how many fewer people call support when you implement some kind of QoE scheme with a middle box. It's almost unintuitive because you think, well, how big of an impact can that have? We're just mucking around with packets and latencies. Well, it affects everything. Most of the quality issues that we have are because of congestion and buffer bloat in some remarks. Gaming becomes better. Zoom becomes better. Everything becomes better and fewer people call in. So that continues to surprise me. The link between doing that and the number of, or sort of the size of your support team needs to be to handle those tickets.
And if I may ask, you guys deployed on cruise ships, right?
We do. Yeah, so I mean, cruise ships are crazy. Nearly dead, overfeds, and all that. 7,000 people in a small area. Well, it used to be pretty bad. You had 7,000 people, and then you have Geo, no Starlink or no Leo, and so you had to share a couple of hundred megabits if you were lucky. Now, at least, it's I think 17 or 20 Starlink terminals on a cruise ship of that size. So they're now getting serious bandwidth. But imagine the cruise ships, it's basically all steel. So running Wi-Fi there, there's steel between every room. So you have to have an AP under every chair. And then it still congests. And then cruise ships, they wanna make a lot of money. So $50, $60 per day of Wi-Fi or connectivity is their normal revenues. I guess you guys would like that. But because of that, it's super important that it works well and that you can personalize the services, you can split it into different like you can use this app but not that app, you can do video but not gaming, you can do like, you're a VIP conference user, I'm gonna charge you $200 to do Zoom, etc. So in order to do all of that, you have to have really good application classifications. So you can implement these policies, you have to have good shapers, so you can make the QoE perfect, etc. But that's a fun industry to serve.
Yeah, for us, we're entirely focused on ISPs. So in general, of like non-ISP use cases, I mean, there's some that stretch the limits a little bit, like RV parks and stuff, but they're kind of ISP-ish. But if I expand the definition a little bit, we spend a lot of time collecting data from the rest of the network, not just the traffic. So access points, OLTs, ONTs, APs, and bringing that back and combining it with the QoE data to point out where the problems are and where to make things better. So yeah, a little more expansive definition of QoE there as use cases. This data is super useful for finding problems, but you got to tie it back to other things to get to the root cause.
Okay, so outside of the, I guess, typical ISP deployments, so first and foremost, I have it in my basement. I guess you can count outside of the ISP deployments. Then, of course, we have some RV parks, as you mentioned, and the typical like MDU deployments. And we see overall MDU market growth, and some WISPs, some customers, some ISPs getting into the like MSP deployments for MDUs. And that's where there is a really good play for the QoE, basically to apply the data plans. So that's other thing. But I think the most interesting use case that we have for the QoE, we are actually trying, as colleagues mentioned, Wi-Fi scheduler it's not the best, right? And you know that with ePMP, we're using Wi-Fi chipsets as a baseline at Cambium. And we're basically ripping and replacing what's there for Wi-Fi with our own queuing to improve it. And unfortunately, we cannot use the off-the-shelf FQ cake stuff, but we are highly influenced by what's available in the open source community. So we are putting QoE inside the radio, basically. Yeah, we are limited with the resources, but that's what we are trying to do.
And pretty much, I think QoE use cases cut across all the segments that we offer. Like, for example, ISP is actually not the only domain that we serve. We serve the enterprises and the universities across all sectors. And particularly, for example, in universities, like you have online exams, let's say 1,000 or 2,000 students actually taking an online exam. And we are pretty much actually, like the root cause actually again is Wi-Fi. And the entire university actually is Wi-Fi covered. And so how do you actually make sure that despite that, whatever the drawbacks of Wi-Fi, you make sure that the exams run online and students actually have the same experience. That's a really challenging problem that we actually face. The other one is for the enterprises, I think there is a heavy migration towards cloud. Whether it's Microsoft like productivity suite or Google, and the latency is becoming very critical there. And again, QoE actually use case is pretty much important there. I mean, you don't really want to tolerate. It's not like working on a Word document in your laptop. You are working in the cloud, and that latency is really affecting sometimes depending on a connection, depending on a Wi-Fi, depending on whatever the access technology that you use. I think the QoE actually is not just restricted to the ISP environment. Pretty much everything where latency is critical and wherever the Wi-Fi actually is the access mechanism for the network access, that problem actually will persist until we find a better solution.
Yes, we have around 600 deployments around the world, and 90% of them are ISPs. But we do have some interesting ones, some interesting deployments. Like we've deployed this in airplanes, which are even, I think, worse than ships. We've deployed this. Well, schools and hotels are also they are like small ISPs. Sometimes, some large universities. Also, some large companies that have. We have a couple of mining companies that have. Branches very far apart and with satellite connections. So that they also benefit from all this kind of QoE. I guess in any kind of in the corporate world, there's also variants of QoE that are used in some cases. It's just that in those cases, the pricing is a problem because they have a company can have a 1 gig connection. And it's 1 gig connection is what you get maybe for a few hundred subscribers ISP, and so it's a challenge.
One of the things I love about being open source and having an open chat room is that people tell us the crazy, weird things they're doing with our system all the time, and a lot of them are kind of cool. We've got some cruise ships. We've got a bunch of schools. One of the first times I ever used QoE was for a rural school in Missouri that had 600 computers and 20 meg connection, and it actually made it kind of usable, and that was pretty awesome. That was way back when FQCoddle was new. But we've had some real doozies. The usual, MDU. We found ourselves looking at a message in the chat one day saying, "Can you help? Our country just lost half its backhaul." And it's like, your country? And it's, yep, we're a country in West Africa, and we just had a fiber cut, and there's only 2 strands of fiber coming into this country. So we scrambled, helped them find some hardware, got them going, and got a whole bunch of thanks that West Malawi had bandwidth today and was actually a usable connection. So sometimes you get these great feel-good stories. Sometimes you look at the deployment map and you realize, wait, there's people using this in a war zone? I don't want to ask. It's stuff like that. Open source is great. You literally interact with everybody. I'd say most of our deployments are ISPs. A lot of them are crazy small ISPs in places like the Philippines, where I've been sent pictures of buildings literally with strands of unjacketed fiber hanging down the side of a building, and people just randomly attach them to phone poles and hope it works. And so, trial by fire, it's just lovely that we're able to help.
Thank you very much, guys. So we are getting close with time or to the end, but we will do some fun thing. Yes. So AI, what do you think? AI and QoE. Let's try be fast.
I don't like hype words. So one thing that we did is, as I'm sure every other vendor, QoE is a lot about analytics, trying to figure out how to present a view on QoE, a view on capacity planning, etc., for the operator and the ISP. And it's just endless reporting, one report after another, and everyone wants it different, slice this way, slice that way, etc.
So one thing, our data is in a SQL database in a fixed schema. It's a nice schema, but it's one of the things we did was pretty cool was just use Gen AI to create a prompt interface. So now you can type in your prompt. Who are the most unsatisfied users? Who are the most users that are likely to churn? When will I need to upgrade this link? Like in prompts instead of endless reporting. And it actually worked pretty cool. You wanna check that out, come talk to me later. But building AI into our algorithms, no, not yet. Hopefully not soon either.
This clock says we got 4 seconds. So just very quickly, for us, yeah, it's all about reporting. It's all about the data. And if you're interested in geeking out on buffering stuff, Dmitry and I are in a session at 1:30 where we'll go into lower level stuff.
Okay, yeah, really quick on AI. I guess I'm long enough in the industry, and I remember that it used to be called machine learning, and before that it was called statistics. So that's of course we use it big time. Oh yeah, big data. Sorry, yeah. I missed the buzzwords. So of course we use it everywhere, I guess, in the development and in products, and it will be more of it. But it's not a silver bullet. It's just another algorithm.
It's just like a bandwidth is lie. I think the AI is the most abused word in the industry right now. I think for QoE, actually, we don't actually really use AI as such. It's pretty much plain network engineering. But where machine learning actually comes, AI comes, is really giving a lot of information like the ISP requires. And for that, actually, it will be very, very useful. And we'll be, working on that as well.
We use AI, AI, it's really machine learning with reinforcement learning to just detect situations in which, we see that someone is at 83 megabits and getting into congestion, and then at that point, we try to then apply 82 megabit limit. So we use that in real time to detect congestion points.
So from the ML and statistics point of view, we've been dabbling with using SCORE from Meta to predict seasonal variance and growth patterns. From the chatbot point of view, the killer app for us has been linguistics. We have a team of 4 people and a whole lot of customers everywhere from the Philippines to countries I'd honestly never heard of before they told me where they were. And LLMs are great for, you can ask in Tagalog, how's my network doing? And get a summary that they can read, because the language barrier is a huge issue when you start going global worldwide. And there is no way that 4 of us can learn every language on the planet. We'll try, but the LLM does it a lot better.
So thank you very much to all the panelists.
Thank you.
Thank you. Lots of tech pretty early in the morning, but was it worth kind of listening to what they had to say? I thought it was pretty fascinating. So thank you so much, you guys. You're standing in the back of the room. We do have some tables up here, chairs.